Hello sir, we are introducing our project on real-time system, that is constant bandwidth server algorithm. My name is Deepak Gupta and my teammate is Ashish Singh. Now what is constant bandwidth server algorithm? The constant bandwidth server is an algorithm for providing temporal protection and real-time guarantees to real-time sporadic tasks. What is the basic idea? When a new job enters the system, it is assigned a suitable scheduling deadline and is inserted in the EDF ready queue. If the job tries to execute more than expected, its deadline is postponed to reduce the interference on the other tasks. In this way, the CPS behaves as a work conserving algorithm, thus providing better responsiveness with respect to non-work conserving algorithm. Now, terms and steps used in constant bandwidth server. A constant bandwidth server is characterized by budget CS and QS is the maximum budget and TS is the server time. The ratio QS by TS is the server bandwidth. A fixed deadline DSK is associated with the server initially, it is equals to 0. Each served job Jij is assigned a dynamic deadline Dij equal to the current server deadline DSK. When a served job executes, the budget CS is decreased by the same amount. When budget equals to 0, the server budget is recharged at the maximum value QS and a new server deadline is generated at TSK plus 1 equals to TSK plus the server time TS. There are no finite intervals of time in which the budget is equals to 0. When a job Gij arrives and the server is active, the request is included in a queue of pending jobs according to a given discipline. When a job Jij arrives and the server is idle, if the budget is greater than the deadline minus arrival time into server utilization, the server generates a new deadline DSK plus 1 equals to arrival time of new process plus server time, and the budget is recharged at the maximum value, that is QS maximum budget. Otherwise, the job is served with the last server deadline DSK using the current budget. When a job finishes, the next pending job, if any, is served using the current budget and deadline. If there are no pending jobs, the server becomes idle. At any instant, a job is assigned the last deadline generated by the server. Now the scheduled test can be given of this process. A constant bandwidth server is UP plus US, the processor utilization plus server utilization. The summation of both should be equal to less than 1 and the whole set is scheduled by only and only EDF. Now we have a simple task here with a dynamic sporadic server with the budget equals to 2 and the server time equals to 6. Now the server utilization can be calculated by CS divided by TS, that is equals to 1 by 3, and then maximum budget can be calculated that is equals to 2. Now we have a sample problem with 3 jobs and their arrival time and computation time. When time t equals to 1, the first job arrives and the server and the budget is assigned to the maximum budget, and then deadline equals to arrival time of first process plus server time, that is 1 plus 6 equals to 7. Now at t equals to 4, this server budget becomes equals to 0. Then the server budget is assigned to maximum budget and the new deadline will be equals to the DS, the old deadline plus server time, that is 7 plus 6 equals to 13. At t equals to 5, the job to arrive and that is in queue, in the queue, ready queue. At t equals to 11, when job start to execute, this budget again becomes to 0. Then it is again similarly it is assigned to the maximum budget and our deadline is equals to all deadline plus server time, that is 13 plus 6 equals to 19. At t equals to 15, the new process job 3 arrive and again CS equals to QS and the deadline becomes to arrival time of third process plus the server time, that is 21. Now my teammate Ashish Kumar Singh will continue with the demonstration.
Hello, this is Ashish and I will explain the demonstration part. So the basic software package which we have used is Allegro. It is a game programming library and programming language that we used is C, C++. The IDE which we have used is code blocks. So let's continue with it. What we have done is created a sample simulation for a task set. We have added these values and then resulted the sample simulation. So these are the task set. The 3 simple periodic tasks arrive. The processor utilization is 0.25 and a periodic task arrives at some irregular intervals. So let's continue. These are the basic results that we have got. This is the IDE and the coding platform. This is the basic first window which we will be getting. These are displaying the parameters of the server and the jobs, and then we are getting the results. So, and this is the basic GUI window which we have created for the sample simulation. As you can see, it displays all the periodic tasks as well as the hard and soft jobs, and displays the budget as well as the periodic task sets. There is some problem with the resolution, so we cannot display the third task set, but it is visible and in the code. So let's continue with the demonstration. Before I continue the demonstration, there are some improvements which we have to make. We haven't added any option for interactive input. We have to add that. Also, some graphical optimizations are to be made. Just as I said earlier, it's a resolution problem, and we can precise the server calculations a bit. So let's continue with it. Okay, so this is the IDE coding window which we have coded in. As you can see, we have used the Allegro 5 gaming library. So let's start the simulation. This is the first window. It displays all the basic parameters and what type of processor it is, and this is the sample simulation. Okay, as you can see, we have displayed all the basic needs as well and is precise. There is a problem with the resolution. Let's show it once again. It displays all the basic parameters and resulting calculations, and this is the basic window. As I have said earlier, there is a problem with the resolution, so we cannot display the third timetable, but we will add it further in the code. So this was our presentation, and thank you.